two triangles here, each to determine whether they're congruent. So you should think that through before we discuss it. Pause and do so. Hopefully you've done that. Okay, opposite to 50 degrees, we have side AC. Opposite to 50 degrees here, we have the side DF. So that these are corresponding sides. And what we're going to do is we're going to list the corresponding sides, because the criterion for congruence is that corresponding sides are equal. Okay, well, then AC and DF have to be corresponding sides. That would mean that AC would have to have length 11. Well, that's possible. So but we don't really know that. We don't know that that's 11. Unless we can conclude that this is 11 with certainty, then we can't claim that the triangles are congruent. Now, another pair of corresponding sides would have to be BC and EF. And they would be corresponding because they both have length 4. And if the triangles are congruent, this side couldn't correspond to the side of length 4, because this side, being the remaining side, would have to have a length equal to AB, and this length would then have to be 11. So what we have is a situation where this side would have to be 11, and this side here would have to be 11. But we don't have information indicating that that's so. Now, if, for example, we knew that this was 50 degrees here and this angle was 50 degrees here, then the triangles would be isosceles, and we could conclude that this side equals this side and this side equals this side, so that these two question marks on the 11 would be confirmed. But unless this angle and this angle are both 50 degrees, that's not the case. So we can't establish that. So we can't establish congruence. We can't say for sure that the triangles aren't congruent because we don't have enough information about the angles. So we don't really know for sure the answer to the question, but we cannot claim congruence without further information. So down here we say AB is equal to DF, and you could be misled by the fact that we have sides of 11 and 4 at a 50-degree angle. It kind of looks like they ought to be congruent, but when you get down to analyzing which sides correspond to which, you find that it's not so. So AB equals DF, but those sides are not corresponding sides. BC equals EF, and those would be corresponding sides. Now, okay, now two triangles are going to be said to be congruent if all the sides are equal and if all the angles are equal and one corresponding side is equal. There's three ways we can prove congruence between two triangles. One way is, of course, if all the sides are equal. That ensures that all the angles are equal. That's called side, side, side. This side is equal to this side is equal to this side, and this side is equal to this side. That's side, side, side. Angle, side, angle. If two angles are the same, then since the angles add up to 180 degrees, the third angle has to also be the same between two triangles. And then if you know that one corresponding side, the side opposite one of those angles in the first triangle, is opposite the side of the corresponding, the side is equal to the side opposite the corresponding angle in the other triangle, then you have the criterion that assures that you have all the angles equal and one corresponding side equal. And then you have side, angle, side. If you have a side, two sides, let's say this side and this side, and the angle between them, the angle to which the two sides are adjacent, are the same between this triangle and this triangle, then since two adjacent sides and the angle are sufficient to determine the length of the third side is going to have to be equal on both triangles. So you have the side, angle, side criterion.